Alright, now let's look at the last section of Chapter 5, where we get introduced to the idea of an inverse for a matrix. And basically, let's first start off with what an identity matrix is. Basically, an identity matrix is one in which, after you do the multiplication, the value of the matrix is the same. This is your identity matrix, 1, 1, 0, 0. If it was a 3 by 3, then it would be 1, 1, 1, and all the rest zeros. But note, after doing the multiplication, we end up with the same element by element matrix that we started with. And so the I2 in this case stands for a 2 by 2 identity matrix. I3 would be for a 3 by 3 identity matrix. Now, a multiplicative inverse of matrix A written this way, and so in this case that does not mean that it's 1 over. It's like function notation. When you see a -1 like that as like an exponent, it means it's the inverse. And so basically, if I multiply two matrices that are inverses of each other, I should get the identity matrix. And again, the n just depends on the dimensions. Is it 2 by 2, 3 by 3, or so forth? And in this particular case, it does not matter what the order is between the two matrices. They will give me the identity matrix. And again, that -1 does not mean 1 over. It means inverse. Now, there is a process to find the multiplicative inverse, which is basically similar to kind of solving equations that we did before. We're going to have our first matrix, if you will, inside the brackets, a line, and then we're going to have the identity matrix. So, for example, here we've got 2, 3, 1, 1. That's our matrix. We draw a line, and then on the other side of that, we have our matching identity matrix. In other words, matching in the sense of the same size. And so, basically, the process is very simple, and it's similar to something that we've done before. We want to turn these into 1, 1, 0, 0, so it looks just like this part, and then whatever this part becomes in the process, we will end up with the identity matrix for that second part. So let's go through the process. First, we're going to do -1/2 times row 1, add that to row 2. Okay, and so if we do that, we have half of 2, that would be a 1, but it's a -1. -1 and 1 gives us a 0 there. Half of 3 would be 3 over 2, but it's negative. -3 over 2 plus 1, which would be 2 over 2. That gives us a -1/2. And then we have to also do it on this side as well. And so a half of 1, or a -1/2 of 1, that's -1/2 plus a 0 gives me -1/2. Half of 0, of course, is still 0, so 0 and 1, that stays a 1. Alright, next we're going to take half of row 1, and so everybody in row 1 just got multiplied by 1/2, so 2 became 1, 3 became 3 over 2, the 1 became 1 over 2, and the 0 became stayed 0, of course. Now we're going to take the second one and multiply everybody by -2 because we want to get a 1 there. So -2 times the 0, of course, stays 0. -2 times the -1/2 gives us a 1. -2 times the -1/2 gives us a 1. And -2 times the 1 gives us a -2. But I now have a 1 in this position. And then I need a 0 up here, so -3/2 times row 2 plus row 1 to go in row 1. So, of course, times 0 is still 0, so that'll stay a 1. We have a -3/2 times 1, which plus the 3/2 gives me a 0. We have a -3/2 and 1, so that's -3/2 plus a half, so that gives me -1. Then we have a -3/2 times the -2, which gives me a negative 3, negative 2 and negative, so that's positive 3, added to the 0 gives me a 3 out there. Now note this is 1, 0, 0, 0, or 1, 1, 0, 0. This is now our identity inverse, or our matrix inverse there. Negative 1, 3, 1, negative 2. We can check by multiplying the two together. So here's the original one, 2, 3, 1, 1. Here is the inverse, negative 1, 3, 1, 2. And if we go through the multiplication, note that we end up with the identity matrix, I2. The 2 being, because it's a 2 by 2. So that's the method to get the identity matrix, or to get the inverse matrix. Now, we can then use our inverse to actually solve a system of equations, something that we have done a couple of times before in the chapter, and now we have a new way of doing it. So let's suppose that we had something that looked like 3 equations and 3 unknowns. And of course, this just shows you the positional spots for those coefficients of the x, y, and z. And then over here, b1, b2, those would be some numbers that we have over here. But we can rearrange this to look like this. And, basically, remember multiplication, going across a row and down a column. So A11 would go with the x, A12 would go with the y, A13 would go with the z, and so that gives us all of that. And then of course on this side we have the result, the B1, the B2, and the B3. So if we then label, the first part is A, X for the XYZ part, and B for the B1, B2, B3 matrix, then this has to be true. We can say that this is AX equals B, and if we know the inverse, if the inverse actually exists, then we can multiply the inverse in front of the A, so these two will give me the identity matrix, which means it won't change X, it's like having a 1. But over here we'll also have the inverse times B, and since this part's just a 1, we end up with the result that we have now solved our equation, because this will tell us what x, y, and z are. For example, let's suppose we had 2x minus 3y, x plus 5y equals the 4 and 2. We have separated them into, here are the elements of A, elements of x, elements of b. Now in this case they have just given us the inverse, but we want to see, they've given us the inverse and then we want to use that to solve it. So going back to what we had up here, x will equal a to the inverse of a times b. So inverse of a times b will be this times that, and again these two times those two, and then these two times those two give us our 2 spots. So even though we've got all these fractions, it turns out that this is going to be 20 plus 6 over 13. 26 over 13 is 2. Here we have negative 4 plus 4, so that's 0 over 13, so that's still 0. So we have our answer, x is going to be 2 and y is going to be 0. And we can check real quick. 2 times 2 minus 3 times 0, that does give me 4. 2 plus 5 times 0, that does give me 2. So in fact it does give me the solution for both equations. So that's the method for using an inverse to solve a system of equations. Let's look at some examples. Now, generally speaking, you'll see it written in this form, find the inverse if it exists. In these particular cases, these will exist, but it is not automatic that an inverse always exists. because of the process that we're going through. So here we're going to rewrite it as first the matrix that we're given, a line, and then 1, 0, 0, 1. So that's our starting point. So first we're going to do 2 times row 1 plus row 2 and put that in row 1. So we want to get a 1 here, so if we double that, that's 6. 6 subtract 5 gives me a 1, and then we put the 1 there. So that will be, here will be a 1. Here we double that, that's negative 2. Negative 2 and 2 is 0. We put a 0 there. And then here, 2 times 1 is 2. 2 and 0 is 2, so we put a 2 there. And of course 0 times anything is still 0, plus the 1 will give me 1. So that'll be the result. We have changed the top row, but we didn't do anything to the second row. It remains the same. Alright, so now we're going to go 5 times row 1, add it to row 2. And put that in row 2. And you know, while it's not required, just putting little notes to yourself of what you actually did each time is a really helpful study habit to be in. So again, our goal was to make that a 0. So 5 times 1 is 5. 5 and negative 5 would give me the 0. Now we are not changing the top row at this point. We're just changing the bottom row. So 0 there. 5 times 0 plus 2 is going to leave that as a 2. And let's see, 5 times 2 is 10. 10 and 0 makes that a 10. 5 times 1 is 5. 5 and 1 makes that a 6. And so now that's what we have after our second step. We want a 1 here, so we're just going to go 1/2 times row 2 and leave that in row 2. So again, since all we're doing is affecting row 2, row 1 remains the same. And now this one becomes 0, 1, 5, 3. And so that says our inverse, because notice we have 1, 1, 0, 0 here, our inverse should be 2, 5, 1, 3, like that. So let's go ahead and check and go A times its inverse. So that will be 3, negative 1, negative 5, 2 times 2, 1, 5, 3. So this is what we're going to multiply. So 3 times 2 plus negative 1 times the 5. These 2 times those 2. And then here 3 times the 1 plus negative 1 times the 3. Negative 5 times the 2 plus 2 times the 5. And then over here, negative 5 times the 1 plus 2 times the 3. And so 6 minus 5, 1. Negative 10 plus 10, 0. 3 minus 3, 0. Negative 5 plus 6, 1. there's our identity matrix. This would be equal to I2, 2 by 2 identity matrix. And so our inverse is, in fact, 2, 1, 5, 3. Now, it doesn't mean that you always have to go through all this stuff to check. It's just this is how you could check that your answer was, in fact, correct. All right, let's do the same process for a 3 by 3. So first we'll write it as 2, -1, 0, 4, -4, 1, 6, -3, -1, draw the line, 1, 0, 0, 0, 1, 0, 0, 0, 1. So that's our starting point. Okay, so first off, we're going to go row 2 plus row 1 in row 1. Where I can, I like to pick things that'll, try to, not have fractions when I'm doing things. So, for instance, I could have just divided everybody here by a half, divide by 2, but then that would have given me a half there. So I'm trying to pick steps that won't, I know when I'm just adding and subtracting, I'm going to have whole numbers still. So row 2, -1 and 2, that's 1. -4 and 4, that's a 0. -3 and 6, that's a 3. 0 and 1, that's 1. 1 and 0, that's 1. 0, 0, that's 0. And again, all that will be affected to begin with is just row 1. So everybody else has to be the same. -4, -3, 0, 1, 0, and then 0, 1, -1, and 0, 0, 1. Okay, we're going to do now, let's see. We're going to do 5 times row 3. Well, let's see, wait. Before I want to do that, I'm going to go here next. I'm just going to go row 1 plus row 2 and put that in row 2 because I want to get a 0 here. So I was jumping ahead of myself there. So again, since we're not changing row, that one, that'll stay the same. And row 3 will stay the same. But row 2 will be changed. So row 1 and row 2, 1 and -1, that's a 0, because that's what I wanted to get, 1, 0, 0. And then, let's see, -4 and 1 gives me a -3. Oh wait, excuse me, I'm adding rows 1 and 2. So 0 and -4 gives me -4, and 3 and -3 give me a 0. And then I have 1 and 0, so that's a 1. 1 and 1, that's a 2. 0, 0, that's a 0. So there's that one. Alright, so now we're going to go here, and I'm going to go 5 times row 3 plus row 2, and put that in row 2. Because what I want to do is I want to get a 1 right there. So I've got 1, 0, 0. Now I want to have 0, 1, 0, so let's get a 1 there. So 5 times the 1 minus the 4, that'll give me a 1 right there. So again, since all we're changing is row 2, I can just go ahead and write out row 1. And row 3. These are from over here. So row 1, row 3. And now it's row 2 that I'm going to change. So 5 times 0 plus 0, of course that's still going to be 0. That's why we like to get our zeros in there. 5 times 1 minus 4, that's a 1. 5 times negative 5 plus 0 is a negative 5. 5 times 0 plus 1, that's going to stay a 1. 5 times 0 plus 2, that'll stay a 2. 5 times 1 plus 0, that will go to 5. And so now I have that. Next, I'm going to now go to, let's see, negative 1 times row 2 plus row 3, and we're going to put that in row 3 because I have a 1 here. I want to get a 0 right there. So since what we're changing is row 3, I can go ahead and rewrite the first two. And now let's go ahead and change row 3. So again, negative 1 times 0 plus 0, that's 0. Negative 1 plus 1, that's a 0. So that becomes negative 5. Because negative 1 times the negative 5 becomes a plus 5. 5 and a negative 1. Let's see, right. Negative 1 times that plus negative 1. So that's going to be a negative 4 now. No, it'll be a positive 4. That's right, because it's going to be negative 5 times negative 1, which is 5. 5 minus the 1, that's 4. And then here we'll have a negative 1 times negative 1 plus 0, so that will be a negative 1. Negative 2 times, or excuse me, 2 times negative 1 is negative 2. Negative 2 plus 0 is a negative 2. And then here we have a negative 5 plus 1, which will be a negative 4. So that last row will be negative 4. All right, so in this case, I'm going to go ahead and I'm going to go from here now. And I want a 1 there. So I'm going to go ahead and put in, divide everybody by 4. So 1/4 times row 3. So again, row 1 doesn't change. Row 2 doesn't change. But I wanted to get a 1 there, so 0, 0, 1. Now 1/4 there. 1/4 there. 2 over 4, 1/2, and negative 1 there. Okay, so now that I have a 1 there, I want a 0 right here, so I'm going to go 5 times that, add it to that. So 5 times row 3, add it to row 2, put that in row 2. Now all I'm changing is row 2, so I'm just going to go ahead and write out row 1. And I'm not changing row 3, so I'm going to leave that alone. So again, 5 times row 3. So the zeros don't matter. That won't change anything. So that'll stay a 0. That'll stay a 1. 5 times 1 is 5. 5 and a negative 5 gives me 0 there. 5 times negative 1/4 is negative 5/4. Negative 5/4 plus 1 is negative 1/4. 1 would be 4/4, so negative 5 plus 4 is negative 1/4. Then here I'm going to have negative 5 times, or excuse me, 5 times negative 1/2, which is negative 5 over 2, plus 2, which would be 4 over 2, so negative 5 plus 4 over 2, so that gives me a negative 1/2 there. And then 5 times the negative 1 gives me negative 5, and plus 5 gives me 0. So we got one spot left to do. We want to turn that one into 0. So now I'm going to do negative 3 times row 3 plus row 1 in row 1. So row 1 is going to change, but 2 and 3's aren't. So I have 0, 1, 0, negative 1/4, negative 1/2, 0. And here I have 0, 0, 1, negative 1/4, negative 1/2, and negative 1. And okay, let's go ahead and take care of 1. So 0, basically negative 3 times 0, well, that's 0, so that stays a 1. Negative 3 times 0 plus 0, that stays a 0. Negative 3 times 1 is negative 3 plus 3, that's now a 0. Negative 3 times 1/4 is 3/4, 3/4 and 1. 1 would be 4/4, so 3/4 and 4/4 is 7/4. Then I have negative 3 times negative 1/2, so that's 3/2, 3/2 and 1, which is 2/2, so 3/2 and 2/2 is 5/2. And then here, negative 3 times negative 1, negative 1, that gives me 3, 3 and 0, that gives me a 3 there. So, over here I have my 1, 1, 1, all the rest are zeros, so my inverse matrix is 7/4, 5/2, 3, negative 1/4, negative 1/4 here, negative 1/2, negative 1/2, and 0, negative 1. And then if I was to multiply this times my original, I should end up with the identity matrix. And honestly, this will happen a lot of times when you're looking for inverses. They will have fractions in them. So we have found the inverses for a 2 by 2, and this one would be, well, this is what would be the result of a times that. Alright, so let's look at a couple of examples in which we're going to solve some problems. First a 2 by 2, 2 equations, 2 unknowns, and then a 3 by 3, 3 equations and 3 unknowns. So first, let's look at this case here. So our A would be 1, 1, 1, negative 1. Our X part would be X and Y. And our B would be 5, negative 1. So we're not given an inverse, so let's go ahead and find an inverse in this case. So we're going to start off with 1, 1, 1, negative 1, 1, 0, 0, 1, And let's see, we're going to do row 1 plus negative 1 times row 2 in row 2. So we're not changing row 1 at this point. But negative 1 plus 1, that would give me a 0. Negative 1 times a negative 1 would be 1. 1 and 1 would give me a 2. 0 is going to be 0. 0 plus 1, so that gives me a 1. And then negative 1 plus 0, that gives me a negative 1. Okay, so that's the first thing we did. Alright, next, let's do half of row 2. That turned that 2 into a 1. And so we're not changing row 1. But here we have 0, 1, 1/2, and negative 1/2. Alright, so we want to get this one to be a 0. So we're going to do negative 1 times row 2 plus row 1 in row 1. Won't change row 2. 0, 1, 1/2, negative 1/2. So negative 1 times row 2, so negative 1 times 1 is negative 1, and 1 makes that 0. Of course, 0 and 1 is still 1. Negative 1/2 plus 1 gives me a 1/2. Negative 1 times a 1/2, negative 1/2 is a positive 1/2, which puts a 1/2 up there. Okay, and so my inverse is 1/2, 1/2, 1/2, and negative 1/2. As I said, a lot of times you will get fractions in your inverse, even though you didn't have any in the original form. So, x will equal the inverse times b. So, we're going to take our 1/2, 1/2, 1/2, negative 1/2 times 5, negative 1. So x will equal 1/2 times 5 plus 1/2 times negative 1 and then we'll have 1/2 times that again, and this time we'll have negative 1/2 times negative 1. So that's going to give me 5/2 minus 1/2, so that's 4/2, which is 2. And this will give me 5/2 plus 1/2, which is 6/2, which is 3. And so our answer is basically x is going to equal 2 and y is going to equal 3, or 2, 3, the intersection of two lines. Let's go up here and check real quick. 2 plus 3, that does equal 5. 2 subtract 3, that does equal a negative 1. So this is the solution. All right, one more case. Now, in this particular problem, if you look all the way back up at the beginning, you'll see that, in fact, the coefficients match what we had up here. So, if you look at the first part, 2, 4, 6, there's my 2, 4, 6. Then I had -1, -4, -3, -1, -4, -3, and then 0, 1, -1, 0, there's no x, +1 for the y, -1. So that, in fact, would have been our A in this case. Now, we already went ahead and found, so from problem 2, we already have our inverse. Our inverse is the 7/4, the 5/2, the 3, the -1/4, -1/2, the 0, and the -1/4, -1/2, and the -1. So we already have that, and since we already got our inverse, we can now go ahead and simply say, well, then x is going to equal the inverse times b. So x will equal our 7/4, 5/2, 3, -1/4, -1/2, 0, -1/4, -1/2, -1, and that will be times those numbers, 4, 8, -4. So multiply all those and we'll have our answers. So first off, 7/4 times 4 plus 5/2 times 8 plus 3 times -4. Then we have -1/4 times 4 plus -1/2 times 8 plus 0 times the -4, and then -1/4 times 4 plus -1/2 times the 8 again, and then this time -1 times the -4. So 7/4 times 4, that's 7, plus 5/2 times 8, so that'll be 20. 7 and 20, 27, 27 minus 12, 15. Here we'll have 1, actually -1. Here we'll have -4, so -1 and -4 is -5 and 0, so -5. And then here again, -1, -4, so that's -5, -5 plus 4 is a -1. And so our answer is 15, -5, and -1. And we can see, for instance, in the last one here, -5 subtract a -1 would give me -4. Here we would have -15. This part here would be plus 20. So that's a -5, -5, and then subtract, wait, no, that's negative, let's see, that's a -15 plus 20, so that's 5, 5, subtract a 3 times -1, so that's 3, 5 and 3, that is 8, so in fact these are working. 2 times 15, that would be 30, 30 minus 4 times negative 5, that's 30 minus 20, that's 10. 10 minus 6, that does in fact give me 4. And so we have actually solved a system, 3 equations and 3 unknowns using the inverse that we got from problem 2.